Short answer questions of part 4. Getting started with number 1, right? It wants you to graph y equals 3.2 times 1.8 to the power of x, right? What am I going to do for this one? I'm going to put that into my calculator, and the actual graph isn't going to help me, right? But if I go to the table function, I'm going to try to basically plot as many points as possible, right? So if I look, I'm going to start at 0 to get my y-intercept. 0 is going to be 3.2, so I'm going to go 1, 2, 3 to like 3.2. I'm going to go down next to 1 and 5.76, so 1, 1, 2, 3, 4, 5, a little bit closer to the 6. And then my last one that's going to fit is 2 and 10.3, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10.3, or almost like 10.4, right? As long as your points are close, you're good to go. I would say try to fill up as many as you can. So I'm going to even go back down to like -1, which is 1.77. -2 is 0.98. And then -3 is 0.54, right? If you fill in a bunch of points like this, now you can graph it, and you just know that it can't cross the x-axis, right? Because it can never go below 0. So even if I just start from here, right, just draw up and try to do as best as I can with this mouse, right? Arrows on both ends, I'm good to go, right? Just make sure you put the points, because if you make your line and it looks weird and starts going like straight up, you might lose a point because they want to make sure that you get basically the correct points that are inside the coordinate grid. All right, hopefully that makes sense. Going on to number 2, right? Write a recursive formula for this little guy: 8, 20, 50, 125, 312.5, right? We didn't say anything, like we did not do this in class, right? But the idea is you always want 2 pieces for like a recursive formula, right? The first thing is you got to know what a when we started this, right? So a of 1 is what, right? We're always starting a of 1 is 8, right? Because that's like the first part of my sequence. And you want to figure out what the rate is as it's going up. So an easy way to do this is just say take the second one divided by the first one. If I do that, 20 divided by 8, I get, I think it's like 1.5, right? Oh, sorry, 2.5, right? Let me just make sure. 50 divided by 20 is also 2.5. You know, I keep going. 125 divided by 50, 2.5, right? So you'll see it has a constant rate that it's basically being multiplied by each time. So that's going to be my R. And whenever you're doing something like this, right, you're going to say a to the n, because you don't know what the n is. It's going to be your a to the 1, right, is 8. And what is it being multiplied by? It's being multiplied by that rate. And the rate is being raised to n minus 1, right? And this makes sense, right? Because if you check it, well, a to the 1 is what? 1 minus 1 is 0, which means this simplifies to 1, and just 8 times 1 makes sense. A to the power of 2 would be 2 minus 1. So 2.5 to the power 1 is 2.5. 8 times 2.5, ding, 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 50, right? You can put in any value of n here, right? So if they said, what's the 10th like part of the sequence, you could put the 10 in here, and you could get an answer all the way into basically infinity. All right, hope that makes sense. I didn't confuse you more. Number 3, is x plus 3 a factor of 7x squared, or 7x cubed plus 27x squared plus 9x minus 27? I already did 2 examples of, right, the polynomial division in the first video, right? Polynomial division, if I divide x plus 3 by that, right, I know, I divide the big one by x plus 3 and I get a remainder of 0, I know it's a factor. But you can also do that little trick where you can basically find the 0 of the factor, which would in this case would be -3. If you plug that in, right, so I'm just going to say, right, the 0 would be, right, -3. If you plug that in to this, you should also get a value of 0. And that would show you that it is indeed a factor, right? If it basically, it has no remainder, right? That's an example of the remainder theorem. If you did that and you just said, I used the remainder theorem and I plugged in -3, right, which is a 0, you get full credit. I just made a couple mistakes by not putting in the -3 for all these, right? But if I do in my calculator real quick, right, what do I get? 7 times -3 cubed plus 27 times -3 squared plus 9 times -3 minus 27. I put that all in my calculator. What am I going to get? I'm going to get, right, basically that f of -3 equals 0. So yes, it's a factor. Why? Because by using the remainder theorem, my remainder was 0. Cool. Number 4, right? This is like one of these exponential equations. You have a brewed cup of coffee contains 130 milligrams of caffeine. The half-life of caffeine in the bloodstream is 5.5 hours, right? And this time we got to write a function, C of t, to represent the amount of caffeine in the bloodstream t hours after drinking 1 cup of coffee. So you got this little C of t, right? I'm just going to basically put out the C of t. And I know, right, C of t, right, basically any exponential function has C of t is equals to like C of 0, right, which is like the initial value times some sort of rate, right, raised to like time, right, like the amount of time that the exponential is going on for, right, that's an R. So in this case, right, I know, well, what's my C of 0? My cup of coffee contains 130 milligrams of caffeine, right, so that's my C of 0. Well, what's my rate? My rate is a half-life, right? So that means this is one of those special cases where it's not doubling. If it was doubling, it would be 2. If it was tripling, it would be 3. If it's a half-life, my rate is 1/2. And it's being raised to, well, the t is still there, but it's being divided by the half-life, which is 5.5. And at the end, what does it all equal? It still equals C of t, right? You'd be completely correct if you answer it just like this, right? In my head, right, the reason why the half-life goes on the bottom here is because after, if I put in 5.5 hours over here, what would it simplify to? 1, right? So basically it means like, right, after kind of like 1 cycle of the half-life, you'd be losing half of your, the caffeine in your brewed cup of coffee, all right? This piece up here is super important though, right? The initial times the rate raised to the power of the time that you're going for. All right, cool. Number 5, right? You have Marcus as a long distance walker. In one race, he walked 55 miles in t hours. In another race, 65 miles in t plus 3 hours. I mean, I don't know who's a long distance walker, but you know, that's a boring sport. His rates are shown in the equations below. You have R equals 55 over t and R equals 65 over t plus 3. We know that he walked at what? An equivalent rate, right, for each race. Determine the number of hours that each of the 2 races took. So I know, right, equivalent rate means, right, I have an R over here and R over here. What do I want to do with these? I want to set them equal to each other, right? 55 over t equals 65 over t plus 3, right? You got a bunch of different ways to do this, right? Like I could multiply by the least common denominator, like for some of those like bigger, they call them like the rational equations. What am I going to do here? Guess what? I have a proportion, right? So I can just basically do like the little butterfly method, right? And multiply, cross multiply, right? And I would get what? 55 times t plus 3, which is just 55t plus 165. And what does it equal? It equals just 65 times t, which is 65t. If I subtract 55t on both sides, I'm left with what? 165 equals 10t. I divide by 10 on both sides. What do I get? 165 divided by 10. T equals 16.5, right? But I'm not done yet, right? I found t, but I want to know how many hours each of the two races took. So if I look at race number one, right? Race number one is just what? T, right? So race number one is going to be 16.5 hours. And race number two, right? And this actually tripped me up, right? I probably would have lost a point for this one. Race number two is 16.5 plus the 3 hours at the bottom, right? Because that's how long it took. So race number two would be 19.5 hours. And you're good to go. Hopefully this video helped and it wasn't too long-winded. See you in problem set or in part 5.